Kaleigh, here is your second video you asked about. So we're looking at the homework problems here on page 491. All right, so the first question is here. Just ask us to identify the parameters of the parent function f of x. Predict the effect of the parameters on the parent function f of x equals e to the x. Okay, remember e to the x, or graphing e to the x, is just like 2 to the x or like 10 to the x. It's an exponential growth curve, okay? So when you go to graph e to the x, it's going to look something like this, okay? Where you have that, exponential growth going off to infinity and stuff like that. Okay, so the parameters still affect e to the x just like they would any other exponential function. So here we see right here, we have x minus 1/2. The minus 1/2 is in with the x, right? So that's going to affect moving left or right. Since it's a minus 1/2, we're going to go right 1/2. Okay? Since, again, our function is e to the x here, when you see f of x minus 1/2 like that, that's really saying it's really saying g of x is e to the x minus 1/2 power, like that. That x minus 1/2 goes up in the exponent there. Okay? Number 4. We have a minus 5/2, but it's on the outside. So what's that going to look like? It's going to look like something like this. E to the x minus 5/2. We have a minus 5/2 on the outside like that. It's not up in the exponent, right? It's like subtract 5/2 on the outside. That means we're going to go down 5/2. Okay, oops, I forgot. I was supposed to identify. Actually, I think it just said in the directions to only identify the transformations. You don't need to worry about doing the, make sure about that. Pretty sure I said I only do the transformations. Yep, transformations only. Okay. Negative 1/4, so that's going to be, again, we're multiplying here, and it's multiplied by negative 1/4. So it's going to be a flip over the x-axis, and a vertical shrink because it's 1/4. Okay? And then finally number 6, again multiplying, but it's by 27/2, which is bigger than 1, so it's going to be a vertical stretch by 1/2, or by 27/2. Like, so 13.5 times bigger, Again, if you're curious, this function would actually be negative 1/4 times e to the x, like that. This function here would be 27/2 times e to the x. Okay, but all those transformations are still, the same as any other transformation we've seen for all of our functions. All right, I'll go ahead and do 8 and 12 here since they are, kind of different. So identify the reference points. Don't fret too much about that. We're just going to draw the graph. Remember that the main kind of point, the special point that we use for e to the x and all of our exponential functions is the y-intercept, which is the point 0, 1 for the normal parent function for any of our exponential functions, okay? For any untransformed exponential parent function, okay? It's 0, 1. We can see here that minus 1 there with the x, we're going to shift, so we're going to take that 0, 1, okay? But that minus 1 there is going to shift things which direction? Okay, should shift things to the right one, and this plus 2 is going to shift things up 2. So our new, kind of like a special point there, is going to be right 1, so it's going to be at 1, and then up 2, it means it'll be at 3. And then you can just create a little table. Okay, put 1 and then 3, in there like that, and we'll go back 2, and we'll go forward 2. Okay, and we'll draw a graph. So I've put in 0, okay? And again, at this point, you're going to have to kind of get a graphing calculator or something like that because, we don't know how to evaluate e to the power there very easily. Okay, I can do it, just like with e still in it. So if I put a 0 in there for that x, it'll be 0, take away 1, which is going to be, negative 1, and it's e to negative 1, so that's going to be 1 over e, and then plus 2 is going to be that value. And then negative 1, if I plug in negative 1, then I'll have negative 1 minus 1, which is negative 2. E to the negative 2 is 1 over e squared plus 2. And then if I plug in 2 and 3, Well, plugging in 2, it's going to be 2 minus 1, which is 1. E to the 1 plus 2 is just e plus 2. And this will become e squared plus 2. Okay. Basic shape will still be very similar here, so I'll just do my graph like maybe over here. Okay, so again, 1, 3 is our basic point there, and you know, let's see, that up 2 means our normal horizontal asymptote at 0. Okay, for the parent function, it's going to be now up 2 at 2. So I have this. Whoops. There we go, horizontal asymptote there. And the graph's going to look something like this. And again, you can kind of like, you know, get those more precise decimal values, or those decimal values that help you kind of get it. But that's what the graph shape's going to look like, okay? The domain, you can use your table on your graphing calculator or something like that. Domain will be negative infinity to infinity. The range, well, what's the lowest y value we're going to get to here? Remember, we have this horizontal asymptote that was shifted up 2, so it's now at the point, or at the y coordinate of 2, so range is starting at 2, going to infinity. Okay, we are not going to hit 2, so notice there's a parenthesis there. We don't actually hit the 2, we approach it, we never get to it. Okay, and then number 12, okay, you can see here that we've got a graph of an exponential function, and we're supposed to come up with its function. Okay, so e is going to be our base. We can see here that we're shifted up 3, right, because we have a y equals 3, our horizontal asymptotes at 3. We're also left 2. So let's see here. We have y equals, I don't know what my a value is yet, so I'll hold off on that. But again, we know for sure that we're shifted left 2, so plus 2. I'm shifted up 3, so plus 3 like that. And then we'll just use this point to figure out what a is. We're just going to plug it in there to our function. So I'll plug in 8 for y, because that's the y coordinate there, right? And plug negative 2 in for x. Negative 2 plus 2, that's going to be 0. E to the 0 is just 1. So we get 8 equals a plus 3. So a is 5. And so then we have y equals 5e to the x plus 2 plus 3, just like that. And there's our equation for the function. Okay, what's the domain? Domain, negative infinity to infinity again. Okay. And what's the range? It's a set notation. We're using interval notation because it's just so much easier that way. Range, well, lowest y value is going to be at that 3 there. Again, we don't get there. What's the highest y value? Well, it's going to go to infinity. So there it is. Okay. All right, get the next 2 videos here to you.